Assalamualaikum. Hello, we are from Dirgantara Innovation team. My name Muhammad Alfandi Pramana Lubis, majoring Aerospace Engineering.
My name is Oki, majoring Aerospace Engineering.
My name Pandikada Asta Prananda Surya Kusuma Wijaya. I major Aerospace Engineering.
Hi, my name is Gloria Haflar, majoring Aerospace.
Hello, my name is Clarissa Damayanti, majoring Air Transport Management.
We from College Aerospace Technology of Yogyakarta, Indonesia. Broadly, presenting technological of innovation in the aviation community with the title Utilization of Aircraft Exhaust or Airport Power Generator using vertical axis wind turbine.
In line with increasing economic growth and population, the need for electrical energy in Indonesia is increasing rapidly. Due to planning errors in the past, the demand for electrical energy has increased much more rapidly than PTPL and Persero. As a result, there were rotating blackouts everywhere. One of the largest uses of electricity in Indonesia is airports, where the airport as the gateway of a region or country. The use of airport electricity is quite large and must not be extinguished, because if the airport's electricity goes out, it will cause fatal things that could harm all parties, including agencies and passengers. And the main source is electricity from PLN with a power of 865 kV ampere for MPH1, 4,300 kV ampere for MPH2, and 231 kV ampere for MPH radar and DVOR. As a result of this amount of power, there are many rotating blackouts due to the lack of electrical power in an area that does not allow the airport to experience power outages. Therefore, we put forward innovative ideas to help power the airport's electricity consumption with the development of vertical axis wind turbine technology, which is placed at the end of the airport runway with a miniature prototype. This vertical axis wind turbine technology works by means of a VAWT placed before the threshold runway with a VAWT height equivalent to the height of the aircraft engine in general. This is when the takeoff and landing aircraft are not disturbed by the presence of a fault, which is usually a high fault. Then, when the plane takes off and lands, the airfoil and vortex thrust behind the neighboring plane blows towards the turbine. The airfoil will drive the fault and generator. A moving generator converts kinetic energy into electrical energy. The electricity will be supplied to the airport's electricity generator to meet the intake of aeronautical, non-aeronautical, and cargo electricity. In the electrical design, the order uses 4 VAWT placed 2 VAWT each. VAWT can produce electricity. With a simple test, if the VAWT is rotated, it can produce a voltage value of 0.01 volt to 5.5 volt. Then, there is the battery, which is the backup. Then, this electricity will turn on the lights at the airport. The original picture looks like this. When the plane takes off, the thrust from the aircraft engine produces a very high rear exhaust air. That's why we innovated to use it to help with the airport's electricity intake. Thank you.